Hey, Broke Dad Builds. Does automotive electrical work intimidate you? And do you worry about wiring up your own rig and trying to make things work without causing any fires or problems or releasing the magic smoke? Well, if so, in this 12-part series that we're gonna have, we're gonna go over all things electrical. In this first episode, we're gonna go over the basics. Hi, let's go to the board because it's cold outside and I'd rather do this right now and it's probably easier to visualize it. So let's talk about this right here. Let's talk electricity, thinking about voltage, right? Voltage, current or amps, resistance. But for voltage, we're gonna think about a garden hose or a hose. And then voltage is the pressure that's pushing the electrons right here. And depending on how hard the pressure is, depends on how fast or how high the current could be. Also depends on the diameter of the wire. Larger diameter, the more current or amps can go and flow through that hose or the wire. So the higher the voltage, the more comes out of the wire all over the load, right? So keeping that in mind, voltage is the pressure, current is the flow, and the resistance is if you get like a kink. Let's say somewhere in the wire or the hose. Then the current, the ability for voltage gets reduced and then it just kind of dribbles out. So that can cause like a light bulb to be dim or, a electric motor to not operate like it should. And speaking of resistance, which we'll talk more about later, but resistance in itself becomes a load. And with resistance in any electrical circuit can build up heat. And over time, you can burn up wires. You can burn up a motor. A light bulb can go out. All because of excessive resistance. Now, that would mean that you'd have to have excessive resistance on the opposite side of the load, after the load. That could cause the bulb to be dim, but over time it can cause excessive current draw to that specific spot where the resistance is. So hopefully that makes sense. So if we look at a basic circuit, and that you can use in a vehicle, you're always going to have a power source, which is your battery, 12 volts here. Then you're going to have a negative going to your frame, somewhere on the frame, because that's going to be your common ground, right? So this is going to be a ground. And you'll see that when we get to the wiring diagram section in the series where we'll go over wiring diagrams and how to read them. But that looks like this. You'll see the little schematic, and you'll see a ground with little lines just going somewhere off in space. That's your common ground, or CG. So then you have, let's go back to your battery. You're gonna have negative, which is gonna be the negative symbol, that's black. Positive, which is positive symbol, that's gonna be red. It won't be like that on schematics, depending on what schematics you look at, but most of them are just gonna be black and white. And then for the circuit, you're always gonna have your positive going to something that's gonna use the electricity, right? It's gonna use that potential, the voltage, which is, for this battery, it's 12 volts. So we got this fuse. We'll talk about more later on, but it's a circuit protection device. So this is rated at a specific amps, right? All fuses have a certain amp rating. So you can have anywhere from 5 to 50 to however high it can go, right? So that just means that if the amperage and this hose, this wire, for some reason goes above its rating, this fuse will pop to protect everything else in the circuit. And then going back to the circuit, after the fuse, we're going to have a load. This is your load. It could be a light bulb, it could be a motor, it could be an actuator, it could be anything that uses that potential, that voltage, the current. So we have a bulb, that's going to be our load. A lot of times you'll see light bulbs on schematics kind of look like this. They look similar to that, but we'll look at that again later on. And then after the load, you'll have a switch. You have something to open and close that circuit. You could have a relay in there, which we won't go over this now, but you get a relay that will control the load. It controls the circuits. Relays control high voltage or high current circuits using low current or low voltage. So it could use a 5 volt or even 12 volt source to control a circuit that has a lot more voltage and current going through it, like a starter relay. So anyways, so you'll have a switch. A lot of times this is a single pole, single throw switch, and you'll have different kinds of switches. You have single pole, double throw, double pole, double throw. It's different kinds. You have momentary switches. You have pressure switches. You have all these different kinds of switches. So anyways, you'll have a switch, and then after the switch, this is a ground control sided circuit. So the switch is on the ground side of the circuit after the load. You're going to have this switch on the ground, so that when it's closed, the light will illuminate. So this is your complete circuit. So just keeping it simple, keeping it basic. So if you can understand just the basic stuff on circuits, you'll understand where to start when you start looking at a problem that you have with your car or truck or project. Always go to your source first. If you have good battery voltage, then you know the battery's good. And then go to your fuse. Is your fuse good? Okay. Then go to your load. Is the light good? The filament burnout? Or, if it's an LED light, did the LED go bad? And then after that, go to your switch. And we'll talk about how to test it with meters, but you can check continuity on the switch. Close it, give continuity. If not, then that's your problem. And then after that, go to the ground side. Do you have it open somewhere on the ground circuit? Or even here on the common ground? Do you have a problem on the common ground? So that's just the process of elimination, right? On doing these kinds of things with electrical circuits. And this is just like I said, series 1. There's going to be 12-part series. We're going to go into detail on everything else, but I hope this helps kind of get you started on your understanding of how to do automotive electrical stuff. We'll go over a lot more later on, but hope this helps. If you like, let me know. Put in the comments. Say, hey, this is great. This helps me understand things. Or, no, I already know this stuff. Why are you telling me baby talk? Or if you think someone else would like it, let them know. But like, subscribe, hit the little notification bell icon, and just let me know if there's anything that you need help with, and comment below if there's an electrical issue that you're having that we all can help out on, right? Maybe I can help you, or anyone else that's watching can help you too. So, thanks. See you next time.